Assalamu alaikum, my dear students. Today I would tell you about the hypokalemia and what effect does it causes on the resting membrane potential, on the stimulus, on the threshold level, on the amplitude, and on the duration. So I would discuss all of these features in this lecture. So first of all, drawing the graph of the action potential like this. So we know that the normal resting membrane potential is minus 90 and the threshold is minus 60. So what happens that sodium potassium ions get entry into the membrane, and that's why the threshold is reached, and then this is the amplitude. And here what happens, this is the whole action potential, and here what happens that this is the repolarization. This is the repolarization. You can see this line is depicting the repolarization. At this stage what happens that uh, to the further leaking channels of potassium further leaks through, and repolarization is you can see that this line is depicting repolarization. So what happens in the hypokalemia? In the hypokalemia, we know that in the extracellular fluid there is the deficiency, or potassium ions are very much less there. So that's why potassium ions from inside the membrane rush through the membrane into the extracellular fluid, because there is the hypokalemia. Potassium ions are less in the extracellular fluid. So that's why what happens that resting membrane potential increases. You must need to remember resting membrane potential increases. How it increases? You can see that those potassium ion will rush through out into the extracellular fluid, because potassium ions are very much less there. So that's why potassium channel would remain open, and it would cause the hyperpolarization. So that's why you can see that here the resting membrane potential will decrease. Let's say it becomes minus 120. So now you can see that there is the greater distance between the resting membrane potential and the threshold level, because of the hyperpolarization. As potassium channels have remained open, so you can say more potassium ions have moved from inside the membrane into the extracellular fluid due to the hypokalemia. So now you can see that there is the greater distance between the resting membrane potential and the threshold level. So another feature I would like to discuss is the hypoexcitability. Now you can see that now there is the hypoexcitability occurring at this membrane. Why there is a hypoexcitability? Because now a very strong stimulus is required in order to reach the threshold, because there is now more distance between the resting membrane potential and the threshold level. So that's why this membrane is hypoexcitable. Now furthermore I will write the threshold level would also increase. Furthermore, strong stimulus is required. You must need to remember these terms. Strong stimulus is required in order to achieve the threshold and further obtain this action potential, and further you can then again receive the stimulus, and this action potential would carry on and contraction would carry on. So strong stimulus is required. Furthermore, now I would like to tell you about the amplitude. Now we have discussed here that strong stimulus is required in order to reach this threshold. So due to the strong stimulus, the amplitude would also be greater. So we will write here amplitude would be greater here. Now talking about the duration would be very much less. This is the very important point. Why the duration would be less? Because we have discussed here that there are very less potassium ions here in this region. So the potassium ions would rush through. More potassium ions would move out from the membrane into the extracellular fluid. So that's why due to this fast movement, what would happen, that duration of this action potential would be very much less. You can see that the duration would be very much less. Okay, so duration is less. Furthermore, we will talk about, as the duration is less, so the propagation would be, we can denote it as fast propagation. So there would be fast propagation occurring in the case of the hypokalemia. So in this lecture I have told you about the hypokalemia and what effect does it causes on the resting membrane potential, on the threshold level, on the stimulus, on the amplitude, duration, and there would be fast propagation in the case of the hypokalemia. So hope you have understood my lecture well. Last but not the least, don't forget subscribe my MS lectures. Thank you.